application of Ampere's law to infinitely, or we can say it is long, straight, cylindrical wire. Cylindrical wire. Okay. And let capital R be the radius of the given wire. And this wire is infinitely long. This wire is infinitely long. And let us consider the total I current is flowing through the given cross section area of the wire. How much current is flowing? Let's say I current is flowing. Okay, everyone. So let us consider we have to calculate the magnetic field due to this current carrying wire at the point outside, at the point on the surface, at the point which is inside, at the point on the axis. So at 4 points we have to calculate magnetic field here. Let us consider this point is outside point. So we named as point outside, and this P point is at R distance from the axis of the wire. So case number one, when P is outside. When P is outside. So when P is outside, then R distance is greater than the radius of the wire. Okay. So for the Amperian loop, we have to make a loop with the radius small r. ठीक है, एक Amperian loop बनाना होगा जो कि रेडियस कितने रेडियस का होगा, स्मॉल r रेडियस का होगा. ठीक है, and everywhere from the axis of the wire the distance of the loop is same, that is small r. So the magnetic field over this loop is constant everywhere. ठीक है, so ये हमारे पास Amperian loop है. And also by the right hand thumb rule, since the current is flowing in upward direction, and by the right hand thumb rule the magnetic field is anti-clockwise around this cylindrical wire, so the magnetic field and the loop element is tangential to each other. So keep in mind the magnetic field and Amperian loop is tangential to each other. When it tangential to each other, it means angle theta is equal to 0 degree throughout the loop. Okay, so by applying Ampere's law, that is close integration of B dl cos theta is equal to mu naught I. And what is the amount of current? That is total I amount of current is threading through the loop. ठीक है ना? So here as the angle is 0 degree, so putting here the value cos 0 degree is equal to 1 because of theta is equal to 0 degree. So cos 0 degree is equal to 1 here. So closed integration of dl is equal to mu naught I, and B is constant over here. So integration of dl, it is equal to mu naught I, and it is very clear here. That is what is the meaning of integration of dl. That is the sum of all length elements of Amperian loop. So since we know that integration of dl is equal to 2 pi r, that is the length of the complete loop. इसको इस तरीके से समझ सकते हैं. That is this is dl, this is dl, this is dl, this is dl. When you add all the dl elements of the loop, so which is equal to the circumference of the loop, and the circumference is 2 pi r. Circumference of the circular loop is 2 pi r. So it is B into 2 pi r, it is equal to mu naught into I. So it is magnetic field is equal to mu naught I upon 2 pi r and it is clear here the magnetic field is proportional to 1 upon r. Case number second here, when point P on the surface of wire, ठीक है, जस्ट सरफेस पर है. तो लेट्स से दिस इज P1 पॉइंट, दिस इज P2 पॉइंट, this is P3 point, and this is P4 point. I am talking about here P2 point. Fine, and at this P2 point the small r distance is equal to capital R. ठीक है, this is your first result here. This is the first result here that you have already completed. That is B is equal to mu naught I upon 2 pi R. So we can draw the Amperian loop on this surface like this. ठीक है, जैसी जो रेंज होगी हमारी उसके अकॉर्डिंग हमारा एम्पीरियन लूप यहां पर बनेगा. ये हमारा हो गया एम्पीरियन लूप. ठीक है, अब देखिए ये जो स्मॉल आर डिस्टेंस है, अब ये स्मॉल आर डिस्टेंस कैपिटल आर के इक्वल हो जाएगी, है ना. सो डायरेक्टली व्हाट वी कैन डू, वी कैन सब्स्टिट्यूट द वैल्यू ऑफ स्मॉल आर इज इक्वल टू कैपिटल आर इन इक्वेशन नंबर 1. फाइन, बिकॉज ऑफ ये रिजल्ट जो है वो एम्पियर्स लॉ से मैग्नेटिक फील्ड का रिजल्ट है. सो द सेम रिजल्ट वी विल गेट हियर, दैट इज फ्रॉम इक्वेशन नंबर फर्स्ट putting small r is equal to capital R here. So the magnetic field B is equal to mu naught I upon 2 pi caps R. Okay, capital R. So I is constant through the loop, that is current is constant through the loop, and R is the radius of the wire, so which is also constant. So at every point on the surface the magnetic field is constant here. So this value is constant. So the second result is this value is constant. This is your second result. This is the second result over here. Okay, now when the P point is shifted inside the wire, ठीक है ना, अगर P point को हम वायर के अंदर रखेंगे, this is the loop you have to make. Okay, so this loop is smaller than the previous loop. Okay, so kindly just think about, this is the current is flowing, this is current. So is the equal amount of current is passing through the given loop, that is the third loop? Please tell me. No. फाइन, तो हमें वो लूप कंसीडर, हमें वो करंट कंसीडर करनी है जिसमें से जो करंट लूप से पास होनी होती है. ठीक है ना. सो केस नंबर थर्ड, व्हेन P3 is inside. Fine. So small r is less than the capital R. Current through the third Amperian loop is not same as the previous loop. सो उस करंट की वैल्यू को हमें कैलकुलेट करना पड़ेगा. ठीक है ना. सो देखिए हमारे पास जो रेडियस, हमारे पास जो एरिया था पाई कैपिटल आर स्क्वायर. सो थ्रू द एरिया पाई कैपिटल आर स्क्वायर, हाउ मच करंट वाज फ्लोइंग, दैट इज आई करंट वाज फ्लोइंग. by per unit area, how much current will flow? Because of there is the uniform distribution of charge, there is uniform flow of charge, so uniform current will flow through the cylindrical wire. So it is I upon pi r square. ठीक है ना. देखिए दोबारा से इसको समझिए, पाई कैपिटल आर स्क्वायर एरिया से, यानी कि ये जो हमारे पास एरिया गिवन है, लेट मी हाईलाइट दिस एरिया. ये जो मेरे पास एरिया है, इस एरिया से टोटल अमाउंट ऑफ जो करंट फ्लो होती है, दैट इज कैपिटल आई करंट फ्लो होती है. ठीक है. देन व्हाट इज द करंट फ्लो थ्रू द यूनिट एरिया, दैट इज आई अपॉन पाई आर स्क्वायर. Now we want to calculate the current through the given loop. This one is the loop. इस लूप से हम लोग करंट को डिटरमाइन करना चाहते हैं और इसका रेडियस जो है वो हम लोगों ने पहले ही कंसीडर किया हुआ है, दैट इज स्मॉल आर. सो द current through pi small r square area, it is equal to I upon pi small capital R square multiplied by pi small r square. ठीक है, pi से pi cancel. So the new current is equal to new current, new and total current. ठीक है, it is equal to I r square upon capital R square. So by Amperes law, integration of B dl cos theta is equal to mu naught. The new current is, let's say, I dash. New current is, let's say, I dash here. ठीक है ना? And everywhere the third loop is also tangential to the magnetic field. So theta is equal to 0 degree here. So you can write here, that is close integration of B dl is equal to mu naught into I dash. So B integration of dl is equal to mu naught into I dash here. Now substituting all the values, so integration of dl, we know that integration of dl, it is equal to 2 pi r because of the P3 point is at r distance, that is small r distance from the axis of wire. So it is 2 pi r, it is equal to mu naught. Now substituting the value of I dash here, so this is I r square upon capital R square. Fine. So this r and 1 r I can cancel here. So magnetic field is equal to mu naught I upon 2 pi r capital R square into small r. So this is the general expression. It means it is clear here the magnetic field inside the wire is directly proportional to small r. Okay, this is the third result here. When this P point is situated, at the axis, then small r is equal to 0. So the fourth case here, case number 4th here, when P4 is at axis of wire, so that small r is equal to 0. When it is small r is equal to 0, then what will happen? The magnetic field is also 0 because of at the axis there is no loop you can form. When there is no loop, so the no current will be considered through the loop. When the no current considered through the loop, so that the magnetic field through the loop is 0. And also numerically, from the result number 3, if you will put here the value of small r is equal to 0, then you will get magnetic field 0. Now about its graph, there are 4 results we studied here. Number 1, B is proportional to 1 upon r. Number 2 result, B is equal to constant. Number 3rd result, B is directly proportional to small r. And number 4th result, B is equal to 0. When point is outside, this is the result for outside. At surface, inside, at axis. This is the conclusion. Okay, now let's draw the graph here. Let's draw the graph here. This is the magnetic field here. This is small r distance, origin here. So let's say this point is small r is equal to capital R, and this region is r is greater than capital R, and this region is r is less than capital R. So outside small r is greater than capital R. Here at the surface R is equal to capital R. This is the region. Small r is smaller than capital R. Here R equal to 0. So this is the region. Okay. So here according to the fourth point, the at r equal to 0 and at the axis the magnetic field is 0 here, and up to the surface the magnetic field is directly proportional to the distance, and after reaching when r equal to capital R, here B is equal to constant. Here B is directly proportional to small r, and beyond this point B is inversely proportional to R. So it is B is inversely proportional to R.